intersect in all different ways and form triangles. And what I want to do in this video, we've been given the measures of some of the angles of this angle. That angle and that angle. And what we want, we're given a bunch of lines here that intersect in all different ways and form triangles. And what I want to do in this video, we've been given the measures of some of the angles, this angle, and that angle. And what we want to do in this video is figure out what the measure of this angle is. We're going to call that measure X. And so I encourage you to pause the video right now and try it yourself. And then I'm going to give you this solution. So I'm assuming you've unpaused it and you've solved it, or you've got at least a good shot of it. So let's try to do it. And what's fun about these is there's 21 degrees, 120, so let me write that down. Know that 59 to be 180 minus 59 minus 29, let's see, 100 degrees is equal to 92 degrees. Well, if this right here is equal to 92 degrees, this angle right here is vertical with that angle, so it is also going to be equal to 92 degrees. And now we're getting pretty close. We can zoom in on this triangle down, angles of this triangle. The other one is, and then let me start over actually. Maybe a faster way, but you wouldn't have been able to do kind of this basic steps there. You said, look, this is an exterior angle right over here. It is equal to the sum of the remote interior angles. So 121 is going to be 29 plus this thing right over here. And we ended up doing that when I did it step by step before, but here we're just using kind of a few things that we know about triangles ahead of time to maybe skip a step or two. Although I like to do it the other way, just so we make sure we don't do anything weird. So anyway, this is going to be 129 minus 29, which is going to be 92. And if this is 92, then this is also going to be 92. And then if this is x, then this is also going to be x, going to equal
You're constantly evolving, just like your one-of-a-kind playlists. With Spotify Premium, it's easier than ever to play what you love and expand your library offline. Just download your favorite tunes and take off on your next adventure. Get 1 month of Spotify Premium free. Tap the banner to learn more.
in this first problem over here, we're asked to find out the length of this segment CE, and we have these two parallel lines, AB is parallel to DE, and then we have these two essentially transversals that form these two triangles. So let's see what we can do here. So the first thing that might jump out at you is that this angle and this angle are vertical angles, so they are going to be congruent. The other thing that might jump out at you is that angle CDE is an alternate interior angle with CBA. So we have this transversal right over here, and these are alternate interior angles, and they are going to be congruent. Or you could say that if you continue this transversal, you would have a corresponding angle with CDE right up here, and that this one's just vertical. Either way, this angle and this angle are going to be congruent. So we've established that we have two triangles, and they have two of the corresponding angles are the same, and that by itself is enough to establish similarity. We actually could show that this angle and this angle are also congruent by alternate interior angles, but we don't have to. So we already know that they are similar. Actually, we could just say it just by alternate interior angles, these are also going to be congruent. But we already know enough to say that they are similar even before doing that. So we already know that triangle. I'll try to write it. I'll color code it so that we have the same corresponding vertices, and that's really important to know what is similar. C. EDC. Now, what does that do for us? Well, that tells us that the ratio of corresponding sides are going to have the same, they're going to be the same. They're going to be some constant value. So we have corresponding side, so the ratio, for example, the corresponding side for BC is going to be DC. We can see it just the way that we've written down the similarity. If this is true, then BC is the corresponding side to DC. So we know that BC, the length of BC over DC, right over here, over DC, is going to be equal to the length of, well, we want to figure out what CE is. That's what we care about. And I'm using BC and DC because we know those values. So BC over DC is going to be equal to what's the corresponding side to CE? CE, the corresponding side over here is CA, is going to be equal to CA over CE. CA over CE. corresponding sides. This is the last and the first, last and the first, CA over CE. And we know what BC is. BC right over here is 5. We know what DC is. It is 3. We know what CA or AC is right over here. CA is 4. And now we can just solve for CE. So we can, well, there's multiple ways that you could.
No signal? No problem. With Premium, you can open up a new world of listening possibilities. Download and play what you want to hear wherever you go offline. And with ad-free music listening, it's easier to stay in the zone without audio interruptions. Get 1 month of Premium free. Hit the banner to learn more.
Think about this. You could cross multiply, and you get, which is really just multiplying both sides by both denominators. So you get 5 times the length of CE. 5 times the length of CE is equal to 3 times 4, which is just going to be equal to 12. And then we get CE. CE is equal to 12 over 5. Is equal to 12 over 5, which is the same thing as 2 and 2/5. 2 and 2/5, or 2.4. So this is going to be 2 and 2/5. And we're done. We're able to use similarity to figure out this side, just knowing that the ratio between the corresponding sides are going to be the same. Now, let's do this problem right over here. Let's do this one. Let me draw a little line here so that this is a different problem now. This is a different problem. So in this problem, we need to figure out what DE is. And we all, once again, have these two parallel lines like this. And so we know corresponding angles are congruent. So we know that angle is going to be congruent to that angle, because you can view this as a transversal. We also know that this angle right over here, is going to be congruent to that angle right over there. Once again, corresponding angles for transversal. And also in both triangles, so I'm looking at triangle CBD and triangle CAE, they both share this angle up here. So we've actually shown, once again, we could have stopped at 2 angles, but we've actually shown that all 3 angles of these 2 triangles, all 3 of the corresponding angles are congruent to each other. So we now know, and once again, this is an important thing to do, is to make sure that you write it in the right order when you write your similarity. We now know that triangle CBD is similar, not congruent. It is similar to triangle CAE, which means that the ratio of corresponding sides are going to be constant. So we know, for example, that the ratio between CB is going to be the same, the ratio of CB to CA. So let's write this down. We know that the ratio of CB over CA is going to be equal to the ratio of CD over CE. And we know what CB is. CB over here is 5. We know what CA is. And we have to be careful here. It's not 3. CA, this entire side is going to be 5 plus 3. So this is going to be 8. And we know what CD is. CD is going to be 4. And so once again, we can cross multiply. We have 5 CE. 5 times CE is equal to 8 times 4. 8 times 4 is 32. And so CE is equal to 32 over 5. Or this is another way to think about that, 6 and 2/5. 6 and 2/5. Now we're not done, because they didn't ask for what CE is. They're asking for just this part right over here. They're asking for DE. So we know that this entire length, CE right over here, this is 6 and 2/5. And so DE right over here, what we actually have to figure out, it's going to be this entire length, 6 and 2/5, minus 4, minus CD right over here. So it's going to be 2 and 2/5. 6 and 2/5 minus 4 and 2/5 is 2 and 2/5. So we're done. DE is 2 and 2/5. And 2/5. 6 and 2/5 minus 4 and 2/5 is 2 and 2/5. So we're done. DE is 2 and 2/5. In the diagram at the left, I'm going to here above, where I pasted it up here. Line segment AD intersects BE, and line segment AB is parallel to DE. What is the length of side CE? So we want to figure out the length of side. CE. Now it might jump out at you, at least it looks like it immediately, that the small triangle on the left is going to be similar to this larger triangle on the right. Well, let's feel good about that. Let's prove that to ourselves. And to help ourselves prove that, we're going to remind ourselves that AB is parallel to DE. At least it looks like it immediately, that the small triangle on the left is going to be similar to this larger triangle on the right. Well, let's feel good about that. Let's prove that to ourselves. And to help ourselves prove that, we're going to remind ourselves that AB is parallel to DE. And actually, think about that even, and that we have this is an alternate segment BC of angle 2.7.5. 25 would be 3. So 7.5 divided by 2.5 is 3. So it's going to be 3. So length of segment CE is 2.1 times 3. So the length of segment CE is going to be, what is that, 6.3. If we look down here, we see that is indeed one of the choices. Figure above, triangle ABC is isosceles. So this triangle ABC, so that big triangle, that's isosceles, which means two of its sides are congruent, have the same length. That is side AB. I'll explain it here. Side AB, so side AB here, is equal in length to side BC. So these two sides are equal in length. So we can say that side is equal to that. Actually, I want to be careful just because that looks like I'm saying it from that point to that point. But those two blue sides are going to be equal in length. Triangle DEF overlaps with triangle ABC. Yeah, we see that it kind of formed this Star of David, or kind of the skewed Star of David. What is the value of angle P here? All right, let's work through this. So ABC is an isosceles triangle. And I'm going to draw it separately here. So ABC is an isosceles triangle. This is an isosceles triangle. And an isosceles triangle, if these two sides are congruent, then these base angles are going to be congruent. And they already tell us that this angle up here, is 100 degrees. And we know that all the interior angles of a triangle add up to 180 degrees. So if we call this x degrees and then this is x degrees, then we see that x plus 100 and then if we both are going to be congruent. This little small triangle right over here, once again, we know that the interior angles of a triangle add up to 180 degrees. So if this right over here plus P is equal to value of P is 80.
Let's get scratching.
We've got two right triangles here. Let's say we also know that they both have an angle whose measure is equal to theta. So angle A is congruent to angle B. What do we now know about these two triangles? Well, for any triangle, if you know two of the angles, you're going to know the third angle, because the sum of the angles of a triangle add up to 180 degrees. So if you have two angles in common, that means you're going to have three angles in common. And if you have three angles in common, you are dealing with similar triangles. Let me make that a little bit clearer. So if this angle is theta, this is 90. They all have to add up to 180 degrees. That means that this angle plus this angle up here have to add up to 90. We've already used up 90 right over here. So this angle A and angle B need to be complements. So this angle right over here needs to be 90 minus theta. Well, we can use the same logic over here. We already used up 90 degrees over here. So we have a remaining 90 degrees between theta and that angle. So this angle is going to be 90 degrees minus theta. 90 degrees minus theta. You have three corresponding angles being congruent. You are dealing with similar triangles. Now, why is that interesting? Well, we know from geometry that the ratio of corresponding sides of similar triangles are always going to be the same. So let's explore the corresponding sides here. Well, the side that jumps out when you're dealing with right triangles the most is always the hypotenuse. So this right over here is the hypotenuse. This hypotenuse is going to correspond to this hypotenuse right over here. We can write that down. This is the hypotenuse of this triangle. This is the hypotenuse. This is the hypotenuse of that triangle. Now, this side right over here, side BC, what side does that correspond to? Well, if you look at this triangle, you can kind of view it as the side that is opposite this angle theta. So it's opposite. If you go across the triangle, you get there. So let's go opposite angle D. If you go opposite angle A, you get to BC. Opposite angle D, you get to EF. You get EF, so it corresponds to this side right over here. And then finally, side AC is the one remaining one. We could view it as, well, there's two sides that make up this angle A. One of them is a hypotenuse. We could call this maybe the adjacent side to it. And so D corresponds to A, and so this would be the side that corresponds. Now, the whole reason I did that is to leverage that corresponding sides, the ratio between corresponding sides of similar triangles is always going to be the same. So, for example, the ratio between BC and the hypotenuse, BA, so let me write that down. BC over BA is going to be equal to EF over ED. EF, the length of segment EF over the length of segment ED, over the length of segment ED. Or we could also write that the length of segment AC, so AC over the hypotenuse, over this triangle's hypotenuse, over AB, is equal to DF over DE. Once again, this green side over the orange side. These are similar triangles. They're corresponding to each other. So this is equal to DF over DE over DE. Or we could also say, we could keep going, but I'll just do another one. Or we could say that the ratio of this side right over this blue side to the green side, so of this triangle, BC, the length of BC over CA, is going to be the same as the ratio between these two corresponding sides, the blue over the green. EF over DF. And we got all of this from the fact that these are similar triangles. So this is true for all similar triangles, or this is true for any right triangle that has an angle theta. Then those two triangles are going to be similar, and all of these ratios are going to be the same. Well, maybe we can give names to these ratios relative to the angle theta. So from angle theta's point of view, I'll write theta right over here, or we can just remember that. What is the side of this is the adjacent side over the hypotenuse. So we'll think about AB DF, this triangle, which relative to angle over, this is going to be over, it's an angle adjacent side to that angle that is the opposite side of these things named. So this is theta. This right over here, that by definition is the tangent of theta. And a mnemonic that will help you remember this. And these really are just definitions. People realize, wow, by similar triangles, for any angle theta, this ratio is all.
We all move to the beat of our playlists a little differently. And with millions of songs to discover on Spotify Premium, it's good to know you can listen without hearing ads. Just queue up your songs and get in your zone. Get 1 month of Spotify Premium free. Tap the banner to learn more.
Similar to try this out before we do this together. All right, we want to figure out the tangent of this angle right over here. Now, you might remember from basic trigonometry that tangent is opposite over adjacent. You might be familiar with SOHCAHTOA. If you aren't, I encourage you to review all of the adjacent over hypotenuse and opposite side. Now, they don't give us any numbers here, but they do tell us that this right triangle is similar to this left triangle. And what we know about similar triangles is the ratio between corresponding sides is always the same. So Q in the figure above, triangle, suppose is 4 ln. It's length 3. So the tangent of R is going to be equal to 4/3. We're done. In triangle ABC above, AB is equal to BC. This is equal to that. What is the value of sine of angle CBD minus cosine of angle BAC? Pause the video and see if you can figure that out. All right, now let's work through this together. Before I even look at this expression on the right, let me figure out what else I know about this triangle. So I know what this angle is. It's going to be 34 degrees. How do I know that? Because if I have an isosceles triangle like this, where these two sides are equivalent, then the base angles are going to have the same measure as 80. That this side of these are split over about 80. How do we figure out this AB? We also know that B minus AD over AB, which is DC. So we BC. How do we figure out what this is going to be equal? Well, we know a few things already. We know that AB is equal to BC, so we could rewrite this as AB. We also know that AD is equal to DC, so we could write this as AD. Now this is starting to become quite clear. This is AD over AB minus AD over AB, which is going to be equal to 0. And we're done. In triangle ABC above, AB is equal to BC, so this is equal to that. What is the value of sine of angle CBD minus cosine of angle BAC? Pause this video and see if you can figure that out. All right, now let's work through this together. Before I even look at this expression on the right, let me figure out what else I know about this triangle. So I know what this angle is. It's going to be 34 degrees. How do I know that? Because if I have an isosceles triangle like this, where these two sides are equivalent, then the base angles are going to have the same measure as well. We also know that if this angle is 90 degrees, then this angle has to be 90 degrees as well, because they have to add up to 180. And then we also know if you have two angles in common in a triangle, two corresponding triangles, then the third angle is going to be in common. So we know that this angle is going to have the same measure as that angle there. And we also know that if you have three angles like this that all have the same measure in two different triangles, and you have a side between two of those angles that is congruent, and you have two sides of those triangles that are congruent to each other, and we do. We have this side is congruent to that side, and we have this side is, of course, congruent to itself. Well, then that means that the third side is going to be congruent to the corresponding third side that all have the same measure in two different triangles. And you have a side between two of those angles that is congruent, and you have two sides of those triangles that are congruent to each other, and we do. We have this side is congruent to that side, and we have this side is, of course, congruent to itself. Well, then that means that the third side is going to be congruent to the corresponding third side in the other triangle. These are completely congruent triangles. Now, based on all that, let's address the elephant in the room, so to speak. Let's see if we can figure out this expression. So now let's think about sine of angle CBD. CBD, we're talking about this angle right over here. The sine is opposite over hypotenuse.